Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Nama saya Arisya binti Abdul Malek bernama Matriks A168346. Ini merupakan video presentation bagi subjek Peralatan Nuklear dan Teknologi Reaktor di bawah Dr. Idzat. Jadi bagi assignment ni saya telah pun memilih tajuk Thorium Reactor. Okey, sedikit pengenalan bagi elemen thorium. Thorium is more abundant in nature than uranium, and it is fertile rather than fissile. It can only be used as a fuel in conjunction with a fissile material such as recycled plutonium. Thorium fuels can breed fissile uranium-233 to be used in various kinds of nuclear reactors. Molten salt reactors are well suited to thorium fuel as normal fuel fabrication is avoided. Jadi di sini kita boleh lihat statistik thorium resource di seluruh dunia dan kita boleh dapati bahawa India mempunyai resource yang paling besar bagi elemen thorium. Sekarang mari kita lihat bagaimana thorium boleh dijadikan sebagai nuclear fuel. So, as it was said earlier, thorium is more fertile rather than fissile. So, when it is fissile, it is not directly usable in a thermal neutron reactor. However, it is fertile and upon absorbing a neutron, it will transmute to uranium-233, which is an excellent fissile fuel material. Maksudnya, thorium ni perlu melalui satu proses nuklear untuk bertukar menjadi uranium-233 yang lebih sesuai sebagai bahan fuel. All thorium fuel concepts require thorium-232 to be irradiated first in a reactor to provide the necessary neutron dosing to produce protactinium-233. This normally emits an electron and antineutrino by beta decay. Then another electron and antineutrino will be emitted by a second beta decay to become uranium-233. Di sini merupakan gambar rajah bagi thorium fuel cycle. So, firstly, the natural thorium will absorb a neutron from fission and becomes thorium-233. And then thorium-233 decays quickly to protactinium-233 and then decays again slowly over a month to uranium-233, an ideal fuel. So uranium-233 fissions release energy and neutrons to continue the process. Now we will see what is the future of thorium reactor. With huge resources of thorium, India has planned to utilize thorium for large-scale energy production as a major goal in its nuclear power program. The first proposal of utilizing a three-stage concept was introduced at the University of Chicago in 1944. First, pressurized heavy water reactors and light water reactors fueled by natural uranium producing plutonium that is separated for use in fuels in its fast reactors and indigenous advanced heavy water reactors. Second, fast breeders reactors will use plutonium-based fuel to extend their plutonium inventory. The blanket around the core will have uranium as well as thorium, so that further plutonium, particularly plutonium-239, is produced as well as uranium-233. Thirdly, advanced heavy water reactors will burn thorium-plutonium fuels in such a manner that breeds uranium-233, which can eventually be used as a self-sustaining fissile driver for a fleet of breeding AHWR. In all of these stages, used fuel needs to be processed to recover fissile materials for recycling. Right now, India is focusing and prioritizing the construction and commissioning sodium-cooled fast reactors in which it will breed the required plutonium, which is the key to unlock the energy potential of thorium in its advanced heavy water reactors. This will take another 15 to 20 years, and so it will still be some time before India is using thorium energy to any extent. Jadi sekarang ni, walaupun ditulis dalam tahun 2018 adalah tarikh siapnya reaktor thorium ni dekat India, iaitu di Kalpakam, tapi reaktor ini masih lagi dalam pembinaan. In, in 2009, despite the relaxation of trade restrictions on uranium, India reaffirmed its intention to proceed with developing the thorium cycle. These are some of the examples of thorium-based reactors. So we have heavy water reactors, high temperature gas-cooled reactors, light water reactors, molten salt reactors, or also known as liquid fluoride thorium reactor, LFTR. Then we have accelerator driven reactors, research reactor Kamini in India, and lastly we have aqueous homogeneous reactor. Sekarang kita akan lihat bagaimana liquid fluoride thorium reactor, iaitu salah satu contoh thorium reactor, berfungsi. Jadi pertama sekali, thorium dan uranium-233 akan dissolve di dalam molten lithium fluoride salt di dalam reaktor tersebut. Semasa proses fission berlaku, haba akan dilepaskan dan free neutrons akan mengubah lebih banyak thorium menjadi uranium-233. Jadi haba daripada reaktor tersebut akan ditransfer ke another loop of molten salt yang tidak mempunyai nuclear materials. Kemudian haba ini akan bertukar menjadi gas helium yang akan menggerakkan turbine dan juga akan menjana generator. So as an emergency measure, if the system gets too hot, a plug designed to melt at a specific temperature releases the reactor's components into dump tanks. Jadi dia kata jika haba terlalu tinggi, ada sejenis plug yang dicipta untuk dicabut dan dia akan melepaskan isi dalam reaktor tersebut ke dalam dump tanks. Dan akhir sekali, because the salt in the reactor is liquid, waste can be removed while the reactor is working. Solid core reactors must be shut down first to remove the waste. Here we have some comparison between the element thorium and uranium. So let's focus on the melting point and boiling point, where thorium has 1750 degrees Celsius for melting point, while uranium has 1132 degrees Celsius for the melting point. So thorium has a higher melting point than uranium, while the boiling point for thorium is 4785 degrees Celsius, while for uranium it has 4130 degrees Celsius, and thorium also has a higher boiling point. So another significant comparison is that thorium is more abundant than uranium. Now let's look at the advantages of thorium reactor. So thorium reactor has stable coolants, where molten fluorides are chemically stable and impervious to radiation. It also has low pressure operation, where coolant salts remain liquid at high temperature. The LFTR cores are designed to operate at low pressures, and thorium reactors are leak resistant due to the low pressure operation. The potential for large leaks is also greatly reduced, and thorium reactor is easier to control. The disadvantages of thorium fuel includes thorium-232 needs to be converted to uranium-233 using neutrons from another source. Now neutrons are expensive to produce and the conversion rate is very low, so the time taken to build up usable amount of uranium-233 is very long. Reprocessing thorium fuel is less straightforward than with the uranium-plutonium cycle. And lastly, uranium-233 is weapon-usable material with a low fissile mass and low spontaneous neutron source. Oleh itu, sekian saja presentation tentang thorium reactor daripada saya. Sekian, terima kasih dan Assalamualaikum warahmatullahi wabarakatuh.